All right, well, thanks everyone for joining us today for the webinar on maximizing your LiDAR investment with Softree Optimal. The webinar will be recorded as always, and anyone that is here will be sent a link to the recording after the fact if you'd like to watch it again or pass it on to somebody else. The webinar today is going to be focusing on using Softree Optimal for resource roads. We'll be doing a wind farm project as an example. So what does Softree Optimal do? It automatically creates a vertical alignment that minimizes a design's earthwork costs. So this leads to reduced engineering time, lower construction costs, and a better road location. Today we'll show you how to achieve these results using Softree Optimal with your LiDAR data. So first we're going to talk about workflow because the availability of LiDAR data has changed traditional engineering workflows. Traditionally, route selection for harvest planning usually would commence with a review of air photos and terrain mapping. Full geometric design is seldom done because it takes too much time. Cost estimates are also not available at this point. The next stage would involve field verification and route selection. If something is discovered at this point, an alternative route would have to be considered, and this step in the process is typically very labor-intensive, as is also the centerline survey stage that would come next. Both of these boots-on-the-ground parts of the traditional workflow are very labor-intensive, and then after that point, we would be going towards detailed design. Detailed geometric design with plans, profiles, cross-section sheets, and at this point only at this final stage is where cost estimates are available. So that brings me to what we are here to talk about today, which is a new workflow with using Softree Optimal with your LiDAR data. So accurate LiDAR data used alongside Softree Optimal has three key benefits, which are improved engineering and route selection, improved field time and more efficient use of field time, and reduced construction operating costs. This is made possible using a new LiDAR-based workflow, which involves using terrain maps, air photos, and LiDAR in your pre-field design stage. And then the field verification, you can quickly locate and optimize your alignments with Softree Optimal at this point, have some preliminary costs, and also do a review of your geometric design or a preliminary geometric design before going into the field. Then the field verification and route selection in your centerline survey, field survey are done as before. RoadEng version 8 is actually going to have a GPS interface, which will make this step even better with your LiDAR data. It'll allow users to take their LiDAR data into the field, check grades, switch back locations, find alternate routes, as well as do cable logging deflection analysis in the field. That's a bit of an aside. Obviously, this webinar is talking about Softree Optimal used within RoadEng, so this ability to use your LiDAR data in the field with the newest version of RoadEng coming out, RoadEng version 8, will make Softree Optimal even more useful. And then at the final stage of your LiDAR-based workflow includes your complete geometric design. At this point, you can do a final alignment optimization with Softree Optimal and get your construction quantities and updated costs. So in summary, Softree Optimal is used in the pre-field design stage as well as in your final full geometric design stages. So a summary of the benefits I spoke about at the beginning. This improved early stage planning and costing and improved usage of field time, which is possible with LiDAR data. And using Softree Optimal alongside your LiDAR data leads to reduced engineering time, lower earthwork and construction costs, and an overall better road location. So before I pass things on to Craig, I'll talk a little bit about the nuts and bolts of optimization. These are some of the variables that Craig will use to perform the actual optimization. So you have your existing ground, which in this case comes from your LiDAR data, also a preliminary horizontal alignment, which Craig will create, and the cross-sectional geometry defined in RoadEng. And then also, once Craig opens the actual Softree Optimal window, he'll have the option to define some costs and constraints. So unit costs include cut and fill costs, movement, material, and loading costs, and any additional costs. And constraints include geometric design parameters such as K values, minimum, maximum grades, control points. It can take into account full bench sections, and also you can define your material movement direction. So those are the 5 pieces of the puzzle that go into optimization. And from there you get your optimal alignment geometry, your costs, and an optimal earthwork movement schedule. So with that, that's quick summary of Softree Optimal and what optimization takes. And with that, I will pass things on to Craig, and he will show you how Softree Optimal can be used for this wind farm project.
Thanks, Cam. Just get my screen going here. I hope everyone can see. So what I'm going to show you is a wind farm project. And what I've got here in Google Earth is 2 alignments, an option A, which is the red alignment, and option B. And I'm coming off an existing road, and I've sketched in these two options in Google Earth. And my objective is to get up to a tower position up on this bluff. Both of these alignments have been created by me. They're not real alignments, but the project itself is a wind farm project. Yeah. Anyway, first thing I should say is that I'm going to be using beta software today, just to show you the look and feel of our new and up-and-coming version 8 release. So I'll be working with that. Also, I know there's some of our U.S. customers in this seminar. This project is going to be in meters, so bear with me a little bit there. Yes, once again, the red alignment on the right here is what I call option A, and the yellow alignment on the left is option B, and I've come off an existing road, and I've sketched these 2 alignments in to arrive at a tower position up on this bluff. So the first thing I did, and I did all this pretty quickly, was to save these options out as KMZ files. And I saved option A out as option A KMZ, and similarly for B. Oops, did those backwards. And then I turned over and went into our terrain program. I have to move this onto the other screen as well. There we go. So what I've got here is a LiDAR data set, and it was a tin model was created and contoured, and so I'm going to insert into this file those KMZ files. I've got things on different screens here. So we'll go option A, we'll plop that in here, and we'll do a conversion from lat long to UTM. There's one alignment. So we'll look at the other one. There we go. So I've taken the KMZ files, I've just simply dropped them into my LiDAR data file, and now I have to change the properties of those to get them to project onto the ground because they don't have elevations. So to do that, I will go into Feature Tools, Feature Properties, and I'll turn off elevations so they become draped on the model. And there you can see in the 3D window, I've got my 2 alignments draped. So all of this is pretty much in preparation for the optimization. There's various ways that you can do this. In fact, you can actually peg your roads in directly in the location design. I've chosen to do it this way just because it's maybe a little different. Now, the actual LiDAR data set that's underneath here, I did a few things before the seminar, and I'll just give you a glimpse at those. So if I select everything, you can see the underlying LiDAR data set, and you'll see that parts of it have been densified or brought in at full resolution, whereas outside they have been brought in at a much coarser resolution. And this is covered really in other seminars that we've done, and it's just really in order to keep the size of the data set down so we can work with it more efficiently. So with all this being done, I've got two alignments, and what I'm really trying to do is to determine which alignment's going to be the least expensive option before I go and spend a whole bunch of time in the field. I just want to evaluate these two quite quickly. And yeah, I found it actually kind of surprising that when I did put these alignments in and came back and did the costing on them, I was quite surprised with the result, and I'll come back to that when we get there. So I've got the two alignments. Now let's switch over to the location design. Again, I have to do this window shuffle. Sorry about this. There we go. And I'm going to create a new design. And I will go into the folder. I'll open up. Before I do that, I think I need to save this terrain file. I will open up that LiDAR data set. And then it's going to ask me for an alignment feature, a starting alignment feature. I'll scroll down the list here and I'll pick option A. Start up my new design. I'll use a standard template cross-section. And my screen has once again moved to the other window, but there we go. So here's how we start out with option A. We've got a plan window showing the sketched-in alignment. I've got a cross-section which has been set up for a wind farm road. And now I want to very quickly get an alignment for this and determine what is the cost of option A. And to do that, I'm going to use our optimization. I'm going to create a new profile. I'll call this prelim. And first of all, I want to choose a reasonable point set. And I'm going to go with a section spacing of 20 meters as a first pass. Then I'm going to choose a type of curve. I'm going to go with curves and tangents slow, and I'll put in a minimum curve length of 20 meters. Now the important stuff, grades. I'm going to put in a max grade of 12% and a K value of 20%. This is a wind farm road, so it's maybe a little higher than the everyday resource road, forest road. So I put in minimum maximum grades and K values and a type of curve. And I'm also going to tell it that at the beginning of the road I want to start on an existing alignment. So I have to put in a control point there, start of alignment. And it's gone and picked up the elevation of the ground at station 0. I can also put in control points at other positions along the alignments if I wanted to, for instance, avoid utilities or match an intersection or things like that. Not important here. The next thing I want to briefly go through, although it's not necessary to mess with this once it's been set up, is the costs. The optimizer requires cost to do its thing. And I have a default table with all my materials in it. And for each material, I've got an excavation cost and an embankment cost. And then I've also got some movement costs. And they're broken down into 3 categories. There can be 3 categories, but I think in most forest road situations, you have either free haul or end haul. And so I've set up this table with costs that represent only 2 types of movement, a free haul movement less than 150 meters, and I've told it that it costs $8 per cubic meter kilometer to move that material, and there's no loading cost. I'm just moving or either pushing it or swinging it around with a bucket. Overhaul here really is end haul, what you would call end haul in the industry, and for that I've put in a dollars per cubic meter per kilometer for that. It's less than free haul, obviously, but there is a loading cost that is associated with it. So if I have to end haul some material, I've got to incur that extra loading cost. So a lot of these things are set up, and I say this every time I do a presentation on Optimal, that you don't have to be perfect with your costs. If you're comparing 2 alignments like I'm doing, if you're using the same set of costs, you're going to get a reasonable comparison between the two alignments. Obviously, the more you work on these costs, the more representative they are, and you know, all those things that, you know, cost estimation and all those things come along with that. But for simply comparing alignments, if you're using the same set of costs, you're going to get a pretty good representation. That's it. That's all really I need to do. If I hadn't talked about the costs so much, I think we would have been all finished with this alignment. So I've got this set up. Let's just do the processing. It's not going to take too long. By the way, this alignment, option A, was about 2 kilometers long, which I think is about 1.5 miles. And option B was a little bit longer, it was about 2.6 kilometers. So one was a little bit longer. One had some perhaps steeper grades in it. I thought originally I was going to get some interesting results. And I'm going to show you what I thought was kind of interesting when I actually ran these 2 alignments. Cam, is there any way for people to ask questions?
Yes, I didn't mention that, but there is a question panel if anyone wants to type in a question. I'm watching it, so if you have any questions, just type them in and we'll answer them as we go. Okay, so it's finished. It's found in alignment. Just zoom in there. So it's automatically found in alignment. It's matched those K values and grades that I gave it. And it tied in, of course, at the beginning of the alignment here. And I can set this current, which I'll do, so we can have a look at it. The way that works is you can have a whole bunch of these, and one of them is current, and the data that's shown for that, the cross sections, the mass haul, everything relates to the current alignment. So I'm just going to set this current. We'll have a look at it. So what I'm seeing down below the alignment, 2 things. I'm seeing a conventional mass haul diagram. The green material is free haul, and the yellow is end haul. And down below here, I've got another representation of the same information, and it's showing the band down here. It's showing the end haul material movement, and the green band here is showing the free haul. So there's an alignment very quickly, and I've got a cost with that. It's $200,000. Fine. Looking at the mass haul here, I say, I don't really want to be moving all this free haul material uphill. So I want to fix that before I go to my other option and have a look at it. And there is a simple way to do that. I can go into my options here,
I go to Constraints, and I'm going to tell the optimizer that I want to move everything backward. So I can only move material backward. Of course, I could control this by station range, but just for simplicity purposes, I'm going to make sure that all the material goes backwards. I'm going to reprocess this. Oh, I know that because I've got a fairly steep grade coming up here, and I've tried to balance the road, I know that if I move the material backwards, I have to have some place to put it. So I'm actually going to add a waste pit at the beginning of the alignment, so it has somewhere to move the material to. So I'll create a waste pit, and there's different types of pits. You can have borrow waste, of course, and you can have what's called a variable pit, which means use the pit if you need to. If it's economic to use it, use it. If I uncheck that, a borrow or waste pit really means it's a demand. It's a volume which must be satisfied, whereas a variable volume or smart pit is a pit that will be used only if it has to. So if you've got a whole bunch of pit locations, the optimizer will actually figure out which ones to use and fill them up. It's very, very smart. So this is a waste pit. There's other stuff in here that you would probably deal with in a more detailed level to do with material qualities. You can control the types of materials if you've got multiple materials, how they travel along the alignment and from and to pits. Let's just go with this. I put a waste pit at station 0, invalid field. What did I do here? Capacity, I don't want that on. That's what I did. It's an infinite capacity waste pit. I'm not going to reprocess that. I'm going to reprocess the whole thing. And I believe this is going to run quite quickly. Again, it's about a 2-kilometer road. If we were doing a 20-kilometer road, I might be looking at a longer wait. It's finished. It's found a new alignment, and this time you can see we've got material moving backward along the entire alignment, and we've got a new cost. It's a little bit more expensive, what you'd expect. So very quickly, I have taken an alignment option and created a profile for it and come up with a cost. If I didn't have to explain stuff, I literally could have done this in 5 minutes. So let me just switch over now to the other option. Just remember that number, 217 for option A. Let's go here to option, let me start a new one. I know my icons are in the other screen. Makes things challenging. I'm just going to start a new instance of location. Minimize this. Come over here and I'll show you my option B alignment, which I did before, and kind of surprised me a little bit. Here it is. Same thing. I did pretty much the same thing I did with option A. And interestingly, I came up with a number that was very close. It sort of surprised me, going back to those two options we looked at. 228,000 versus 217 is pretty much within the, it's very, very insignificant. So which option is better? I would go with option B because it was 2.6 kilometers, and I know that I'm going to have some surfacing cost, so I would tend to focus on that one. But now I have something that I can go out in the field with. I can do a more detailed look at the alignment, look at the rock types, ground types, and so on. Come back and design it fully, with horizontal curves and the whole thing, and I've really saved a lot of time in the whole process. And that is pretty much all I wanted to tell you guys about. Sorry about the mix-up with the screens here. It's a bit frustrating. Are there any questions?
There's nothing in the question panel, but if anyone has a question, got someone that typed in a couple plus signs. I'm not sure if that was a mistake or if you were trying to ask a question, but retype it. Oh, we have a question. Is there an optimizer for horizontal alignment?
That's a good question, and I should have mentioned this before. Well, let me answer your question first. We are working on one. We have one, actually. It requires that you identify a corridor in which to work, and it will move things around within that corridor looking for the best horizontal alignment. It is a work in progress. We're working with the University of British Columbia on it. It's a much harder problem. And right now, when we look at optimizing the horizontal, it normally takes hours to run, if not more. So short answer is yes, we have something. It needs some work, I think, before it's given to people to check out. It's obviously a very valuable tool. And yeah, the one thing I didn't mention in this design, the grades here are not typically steep West Coast grades. And when you're in very steep 100% side hill terrain, vertical optimization isn't really the whole solution. In fact, the optimizer doesn't do a great job because in steep terrain, you typically want to move to full bench cut the whole way and go at maximum grade up the side. And the optimizer just simply doesn't really help you with that. Where the optimizer is good is in terrain that's transitioning, rolling terrain. It's very good at that. But as far as optimizing full bench, steep roads, not so good. We're looking at some other tools and ways to deal with that. But right now, if that's all the roads that you do, you'll get limited value from the optimizer in terms of yeah, you still will have to move your alignment into that full bench position horizontally. Are there any other questions? I'm going to assume there's no questions, Cam?
Yeah, there's nothing more in the panel, and we've already hit 11:30, so I think if anyone has a last-minute question they want to sneak in there, do it, but otherwise I think we'll finish it there. Well, thanks for joining us, everybody. Have a great weekend, and like I said at the beginning, you'll all be sent a link to the recording after the fact if you'd like to watch it again. Thanks for joining
everyone.
us. Bye-bye.